Okay, hi everybody. So my two sections of Chem 2270 are in different places in the notes. So this is where section 2, the class that starts at 11:20, this is where we left off. For section 1, you've already gone through this page, so you can skip ahead. And when I post this video, I'll let you know exactly what time to skip ahead to. But for section 2, let's start here. So we're going to talk about nomenclature. This is how we name molecules. And there is this International Union of Pure and Applied Chemistry. They've generated rules that are used internationally for naming molecules. And this is important because if two groups of scientists in two different countries with two different languages are studying the same molecule, they should be able to communicate their findings across different languages. And so scientists needed a uniform way to discuss molecules and name them, so we know that we're talking about the same thing. So we're going to go through these rules. This is part 1 here because we're going to add to nomenclature notes. So we're starting with a few basic rules today, and then throughout the semester we'll add some more layers to naming when we get to more complicated molecules. But what we're going through today in these notes is foundational for those more complicated molecules. So we want to make sure that we understand this at this time. So step 1 when naming molecules is to identify and name the longest carbon chain. So we're talking about organic chemistry. This is mostly carbon-based molecules. And that's what we're learning how to name here. And so finding the longest carbon chain, I've got a few examples here, but this is the longest continuous chain of carbon atoms. And once you determine how many atoms are part of that chain, you go to this table and find the appropriate prefix for however many number of carbon atoms there are. And then you end the name with "ane" there. So let's look at this first example, and I'm going to number carbons when we do each example here. Now there's only one carbon in this molecule, CH4. So we go to the table, the prefix for the number of carbons is meth, and so this molecule is methane. You've probably heard that name before. That's where that name comes from. We have meth for the prefix and ane for that suffix part. Now we just learned skeletal structures. So this molecule here is 3 carbons. The end is a carbon, the bend is a carbon, and then the other end is a carbon. So there are 3 carbons in this chain. Again, we go to the table. The prefix for 3 carbons is prop. And then we end with ane. This is propane. So that's propane gas that you use like for your grills at home. It has other uses, but that's propane gas. It's 3 carbons. All right, let's do the next one. We have 1, 2. Actually, before I go through it, you might just pause the video, try naming this, and then watch the rest of the video and see if you've got it. So there are 6 carbons. Go to the table. Prefix for 6 is hex. So this is hexane. Now that's as simple as molecules are going to get. If you just have one long carbon chain, nothing else is there, we just count the number of carbons, use a prefix, and then put ane at the end of that prefix. Most molecules are not this simple. There are substituents on molecules, so that's where we're headed next. And when it contains substituents, what we mean by that is something else that's branching off of the main carbon chain. Now there are a bunch of examples in the tables down here. When there is something else in the molecule, like here's a great example to start off with. There are 1, 2, 3, 4, 5 carbons in that chain, but if all we wrote was pentane as the name, that doesn't tell us where the bromine is. There's a bromine on carbon 3 in this molecule. And so when there is a substituent, that's just one example, but when there is a substituent, the identity of that substituent and its location on the main carbon chain has to be specified in the name. A number is used to indicate where the substituent is, And then we put a dash in between letters and numbers when we put the name together. So let's add this note here. Add a dash, like just a dash, between letters and numbers. And this might make more sense when we do the examples on the next page. So here are two tables that show different substituent groups. We looked at bromine, so if bromine is a substituent, the prefix is bromo, and that's added as a prefix, so that goes before the main carbon chain. This name for that molecule that I circled is 3-bromopentane. That's just one example. We've got plenty of examples on the next page as well. And you can see the other halogens are part of the table on the left. Alkoxy groups are when an oxygen is bonded to a main carbon chain, and then that oxygen is bonded to more carbons. Then we have the N3 and the NO2 nitro groups. Those are other substituents. Then you can also have in a molecule a branching carbon chain. So I'm just going to draw an example molecule here. Okay, so we have a number of carbons there, and then let's say one of these carbons had another carbon bonded to it. That substituent, that substituent here, that's not part of the main chain because it's not the longest carbon chain, but it needs to be numbered and named. So the table on the right has all carbon-based substituents, and the names follow the names in our previous table. So if one carbon is a substituent, we have meth there, but then the end of the prefix name is YL. 2 carbons, ethyl, 3 carbons, propyl, and then the remaining groups here, at least most of them, are some specially bonded groups. And we'll come back to these to talk about how to name and use these prefixes. Let's go ahead to the next page and try some of these learning checks. So this first molecule here, we need to first identify longest carbon chain. That's a continuous chain without branching. So if we number carbons, we could do 1, 2, 3, 4, 5. Another option would be 1, 2, 3, 4. But the numbers I put in blue there, that second set, they don't provide the longest carbon chain. A 4 carbon chain is shorter than a 5 carbon chain. So the main carbon chain here is 5 carbons. So that will be the first part of the name, and we're just going to break everything down before putting the whole name together. So longest carbon chain is 5 carbons. So if we look back up to that first table, the prefix for 5 is pent, and then we add ane at the end of the name, so pentane. I'm going to highlight this to show those 5 carbons are represented by the fraction of the name pentane. Now there's another carbon that's part of this molecule that also needs to be named. It's just not part of the longest carbon chain, and that's the one right there. So we have a substituent on that chain. And I'm going to put parentheses S here, parentheses for plural. While this molecule only has one substituent, other molecules may have more than one, and you'll want to find all of them before you put the name together. Okay, so there's one carbon that's part of the substituent. Remember, this is just a CH3 group at the end. That's what the skeletal structure represents. So if you go back to substituent naming for a 1 carbon chain, that is methyl. Then the other thing we need to do is specify which carbon that substituent is branching off from. And that's the carbon on the main carbon chain, the longest carbon chain. So we have to number each carbon in the chain. We have to start from one end and go to the other. You don't necessarily have to start on the left and go to the right. It depends, so that you achieve the lowest number possible for the substituents. Now, in this particular molecule, it doesn't matter if we start from the left or right, because either way, you would number the carbon that has that methyl substituent as carbon 3. So even if we numbered with the carbon on the right as being number 1, 2, 3, 4, 5, well, it doesn't matter because the methyl group is still on carbon 3. Now, sometimes it will matter, and then you'll want to double check that you have the correct numbering pattern. So we have 3-methyl. There's that dash that you put in between letters and numbers. So the name here is 3-methyl pentane. And then we don't put any spaces, just have number dash substituent and then pentane. All right, let's go to, I'm going to save the next 2 examples for class. Let's go to the next learning check where we are given a name and we need to draw the molecule. So when you're looking at the name, I find it helpful to first identify the longest carbon chain, butane. All right, well, butane's our longest carbon chain. If you go back up to the table, that's a 4-carbon chain. So I'm going to draw 4-carbon chain. Might as well number it. And then let's go back to the name. We have 1 substituent, bromo, and it's on carbon 1. So we need to add a bond to carbon 1, and then bromo represents bromine. So there's 1 bromobutane. Again, let's save the second learning check for class. But you might try it before class. You can try all of these, and then that will give you more time to ask questions if you do have some. Okay, so now if there are more than 1 of the same substituent present, we add a prefix before each substituent name. So in this molecule, this example, we have, let's find the longest carbon chain. It's going to be a 4-carbon chain. It doesn't matter where you start on the left. If you start in the other 2 methyl groups, the longest continuous chain you can generate is a 4-carbon chain. So let's number these. 1, 2, 3, 4. So if we were to put the name together, longest carbon chain, now I know the name's already provided. I just want to go through the steps so we can understand why the name looks that way. Then if we look for substituents, we have a methyl on carbon 2, and we have another methyl on carbon 2. So each of these, here's one. I'm just going to highlight that as purple, and then let's just use orange for the other. So we have to specify that there are 2 methyl groups on the same carbon. So when you put the name together, we still need to list the number for each substituent. And when you have 2 numbers next to each other, you put a comma between them. 2, 2, And then here's where we use a prefix. We have 2 methyls, so we say dimethyl butane. If there were 3 of the same group, then you would write 3 numbers and then try whatever the group is. In this case, we don't do trimethyl because one of these methyls are part of the longest carbon chain. How about we do another example? We're just gonna add a few different things. Let's see, where do we have room? I'll do it off to the side over here. Oops. Okay, so this will be a separate example. I'll just zoom into this. So here we have, let's find the longest carbon chain. I'm counting 6 carbons. So hexane. Then we have substituent fluorine. We have 2 chlorines. I'll just highlight those as the same color. And then we have a methyl. So let's write fluoro. We have 2 chlorines, so that will be dichloro. Then we have a methyl. And then we need to figure out the numbering. If we number from the left, and I will do that with pink numbers, we have 1, 2, 3, 4, 5, 6. So that would be 2 fluoro, 2, 5 dichloro, and 3 methyl. If we number from the right side, which I will do with blue numbers, be 1, 2, 3, 4, 5, and 6, we would have numbers 2, 4, and then 2 5s. So overall, numbering from left to right gives us lowest numbers. So more numbers are lower in value than if we number right to left. So pink numbers are better than blue numbers. If we use blue numbers, we would have a 2, a 4, and then 2 5s. In the name, having a 2, a 2, a 3, and a 5 is lower numbers overall. We will get more practice with this. Just want to introduce that idea here. Okay, so we're sticking with the pink numbers. Then if we put the name together, I'm going to scroll up real quick. These substituents are ordered alphabetically. So when you put the name together, we order these alphabetically. Order the substituents alphabetically. The di part doesn't count, any of those prefixes, so we're looking at F, C, and M. C comes first alphabetically, so this will be 2, 5, dichloro. Next is fluoro, 2 fluoro. Notice the number or the dashes between numbers. 2 fluoro, 3 methyl, hexane. And that is the name of this molecule. Last thing I want to say in the video is that if you're looking at a molecule where the longest parent chain is a ring, Then we add the word cyclo before the name for the number of carbons within the ring. So here we have 1, 2, 3 carbons. This chain is called cyclopropane. Pro for 3, cyclo for being a ring, and then ane is the end of the names. Here we have 4 carbons, that's cyclobutane. Next there's 5, that's cyclopentane. And then 6 is cyclohexane. Okay, so there are some basic rules to start off naming. We will go through these learning checks in class and then move on to conformations of alkanes, and you should bring your model kit for that part. But you might try some of these names ahead of time, and then I'm happy to help, go through these names. We'll go through all of them in class. All right, thanks everyone. I'll see you on Tuesday.